Hello everyone, so today in this video we are going to learn as how to convert a number that is in the binary number system to decimal number system using a simple code in C++. Okay, so first of all, before going directly on how to convert it in C++, let's understand as how to do that on a pen and a paper. Let's say that we have a decimal number that is 101. Let's just give some space and write it, so that will be better. All right. So here we have 101, that is a binary number. On the next line, from the right side, just do the numbering, okay? So this one gets the number 0, this 0 will get the positional number 1, and this one will get the positional number 2. Just like in coding we do. So this one will get the positional number 2, this will get 1, and this one will get 0. Start the numbering from 0 from the right side and then just follow the order. Now next what we have to do, there we have a face value, let's say that is 1 and its index is 0, right? So we just raise this number, the index, that is 2 to the power 2, right? So 2 to the power 0, that is 1, and 1 multiplied by 1, that is again 1. So we will just write 1 over here, and we will just do the same thing here as well. So this is 0, 0 times 2 to the power 1, that is 0, and at last 1, 1 times 2 to the power 2, 2 to the power 2 is 4, and so 1 times 4 is 4. Now we just have to add all the number here. So 4 plus 0 plus 1, that comes out to be 5. And well, indeed 5 is actually the decimal equivalent of the binary, that is 101. I hope that you understand the logic what I was trying to explain here. Now we will do the same thing in coding language, right? So let's just paste the formalities that we have. Now what we are going to do, first of all, simply the most basic thing that we are going to do is to input a number in binary equivalent number system from the user. So let's just output an instruction for the user, right? Enter a number in binary. So once we are done with that, I will just end this line since it is required. Now let's just make an integer called bin as to store the binary equivalent, and let's just input it through the cin command. So now the user has inputted a number that is the binary equivalent, which we have to convert it in the decimal. Here are some of the necessary variables which we will be requiring. One of them will be remainder, so as to store the remainder when the binary equivalent is divided by 10. What is the purpose of that? Well, the purpose of that is to extract the numbers one by one, as in 101, first extract 1, then 0, and then finally 1 again. So one of the integers that we will want is remainder here. One of them will be a counter integer, like 2 multiplied by 2 every time we get, right? 2 to the power 0, then 2 to the power 1, then 2 to the power 2. So first of all it will be 1, then it will get multiplied by 2, then it will get multiplied by 2 again, and then 2 again. No matter how many times the process will go on, it will keep on multiplying itself by 2. And at last we will require an integer, that is decimal 0, so we can store the decimal equivalent of the number process by process. We will need a loop here. Why are we going to need a loop? We are going to need a loop so the binary number gets reduced by 1 at a time, right? 101. So first of all it's get 10, then 1, and then finally it gets 0. When it gets 0, we know that we do not have to do anything further, and the decimal equivalent have been stored in the curly brackets. What are we going to do? As I have already said, that remainder is going to store the remainder value left after the bin or the binary equivalent is divided by 10. So we will just use the modulus function here. Okay, so as in 101, the remainder, first of all it will be going to store 1, and then 0, and then 1 again. So in the first step the remainder will store 1, and then we can just divide bin again by 10 because we do not need it anymore, right? Now decimal will just keep on adding itself, as I have shown that we have to add it, and we have to add it with remainder multiplied by I, since I is 2 to the power 0 at the first instance, then it is 2 to the power 1, then 2 to the power 2, and so on. And at last what we are going to do is we are just going to increase the value of I multiplied by 2. So only these four commands are required to convert the binary equivalent to decimal. Once the loop is over, we have got the decimal equivalent of the number in the integer, that is DEC or des. Let's just output that integer and let's just return 0 to the command prompt since it was of the integer type. Let's just save the function and try to run it. Okay, so we have the terminal portal here, and enter a number in binary. We have to enter a number binary, so let's say that we are to enter 1100. Okay, so 1100, that is the binary equivalent of 12, and that is well indeed correct. I hope that you liked our video. Do like and do share and do subscribe. Thank you. That's all for